Hello guys, welcome back. Today's story, edge computing. What is edge computing? Edge computing is a way of processing and storing data closer to where it is generated, rather than sending it to a central server or cloud. This can improve the speed and efficiency of data analysis as well as reduce the network bandwidth and latency. Edge computing is useful for applications that require real-time or near real-time responses, such as watch devices, autonomous vehicles, smart cities, and cloud gaming. Some examples of edge computing are a smart thermostat that adjusts the temperature based on the data collected from seat source in the room without relying on cloud service. A self-driving car that uses cameras and sensors to navigate the traffic and avoid obstacles without depending on a remote server. A game streaming service that delivers high-quality graphics and low-latency gameplay to mobile devices by using edge servers that are close to the users. Edge computing is not a specific technology, but an architecture that can use different technologies such as virtualization, containerization, microservices, and serverless computing. Edge computing can also work together with cloud computing by using the edge for the time-sensitive tasks and cloud for the resource-intensive tasks. What are the edge computing uses causes? Edge computing is a distributed computing model that allows data to be processed and analyzed near the source rather than in a centralized cloud or data center. Edge computing can offer benefits such as improved performance, reduced network latency and bandwidth, enhanced data privacy and security, and increased operational resilience. Some of the use cases of edge computing are autonomous vehicles. Edge computing enables autonomous platforms such as cars, drones, and robots to make faster and safer decisions based on real-time data from sensors and cameras. Remote monitoring of oil and gas assets. Edge computing enables real-time analytics with the processing and storage of data close to the remote assets, reducing the need for costly and unreliable network connections. Smart grid. Edge computing aids in the managing energy consumption by enabling smart meters, sensors, and devices to communicate and optimize power distribution and demand response. Predictive maintenance. Edge computing brings processing and storage of data closer to the industrial machines and equipment, enabling early detection and prevention of failures and downtime. Healthcare. Edge computing enables faster diagnosis and treatment of patients by allowing medical devices, wearables, and sensors to collect and analyze data locally while ensuring data privacy and compliance. Retail. Edge computing enhances customer experience and operational efficiency by enabling smart shelves, digital signage, inventory management, facial recognition, and personalized offers based on real-time data from cameras and sensors. Gaming. Edge computing enables cloud gaming companies to deliver high quality and low latency gaming experiences by deploying their servers closer to the gamers. Smart homes. Edge computing can bring the data storage and processing centers close to the smart home devices such as thermostats, cameras, speakers, and lights, reducing network costs and latency while increasing data security. Augmented reality (AR) and virtual reality (VR). Edge computing can enable immersive and interactive AR or VR applications by providing low latency rendering and streaming of high resolution graphics and audio. Agriculture. Edge computing can enable smart farming by allowing sensors, drones, cameras, and robots to collect and analyze data on soil, weather, crops, pests, and livestock, while optimizing irrigation, fertilization, harvesting, and animal welfare. What are the benefits of edge computing? Edge computing is a distributed computing model that allows data to be processed and analyzed near the source, rather than in a centralized cloud or data center. Edge computing can offer benefits such as improved performance. Edge computing can reduce network latency and bandwidth, resulting in faster and more reliable services for users and applications. Enhanced data privacy and security. Edge computing can limit the exposure of sensitive data by keeping it closer to the devices and users, while also complying with different regulatory and compliance requirements. Reduce operational costs. Edge computing can lower the network and cloud costs by minimizing the amount of data that needs to be transferred and stored in the data center or cloud. Increase operational resilience. Edge computing can enable applications to function even when there is intermittent or no network connectivity, as well as to handle failures and disruptions more effectively. Challenges of edge computing, such as logistics complexities. Managing disparate edge compute network and storage systems is complex and requires having experienced IT staff available at multiple geographical locations at the same time. Bandwidth bottlenecks. Send raw data from edge services to the cloud can compromise security and is often inefficient and cost prohibitive. Edge computing requires more bandwidth across all individual ends of the server. Limited capability and scaling complexities. Edge devices may have limited processing power, memory, and battery life compared to cloud servers. Scaling up edge computing applications may also pose challenges in terms of deployment, orchestration, and synchronization. Data security. Edge computing exposes data to the more risks of theft, tampering, or loss due to the increasing number of devices and networks involved. Edge computing also needs to comply with different regulatory and compliance requirements for data protection. Data access control. Edge computing involves multiple stakeholders such as device owners, service providers, network operators, and end users. Managing data access rights and permissions among these parties can be challenging and complex. What are the latest trends in edge computing? Edge computing is a distributed computing model that allows data to be processed and analyzed near the source rather than in a centralized cloud or data center. Edge computing can offer benefits such as improved performance. 5G connectivity. 5G is the latest evolution of wireless communications and offers some vital benefits for edge computing. It provides new peak speeds and lower latency, which are extremely helpful for applications that require real-time data processing and feedback, such as autonomous vehicles, augmented reality, and gaming. Clock enablement. Clock systems collect real-time data from sensors, which is needed for essential decision making. Edge computing can enable locked devices to process and analyze data locally, reducing the need for sending data to the cloud or data center. This can improve the efficiency, scalability, and security of lot applications such as smart homes, smart cities, smart farming, and smart healthcare. Customer experience. Edge computing can enhance customer experience and operational efficiency by enabling personalized and interactive services based on real-time data from cameras and sensors. Data security and privacy. Edge computing can limit the exposure of sensitive data by keeping it closer to the devices and users while also complying with different regulatory and compliance requirements. Hardware acceleration and virtualization. Edge devices may have limited processing power, memory, and battery life compared to cloud servers. Future of edge computing. There will be so much compute and storage available that we'll start seeing divisions between the edge data centers, even the exist and the cloud. Challenges around data consolidation across the three realms will emerge and multiple ecosystems will start feeding up data from the edge directly. AI and ML will have emerged to such an advanced degree at the edge that more sophisticated autonomous uses are possible. Data management will still be a key factor to consider, but the challenges might look different. Thanks for watching.